All right, hello there. We are on video number 4, and there are a total of 5 videos in chapter 1, so we're actually almost done with this chapter. Don't forget to put your class name up here, and if you want, you can put the chapter and section. So this is 1.4, and we are solving absolute value equations. All right, so we need some information. First, you should know, you probably do know this, absolute value is the distance from 0, is the measure. So it's a measure, which is why it can't be negative. The measure of the distance from 0. Sure, we'll word it that way. Because it's a measure, the answer can never be negative. Now, don't confuse that with something else in a little while when I tell you to make something negative. All right. So the absolute value answer can never be negative. The answer can, however, be either 0 or a positive number. Positive value. Okay, so that's important to know. Absolute value symbols are 2 straight bars that are usually taller than the line that you're on. And anything within here is what would be the distance from 0. So for example, if you saw something that said, what is the absolute value of -8? Well, you've been expected to just say it's 8. Or what is the absolute value of 8? Well, that's also 8, right? But we're not going to be dealing with problems like that when we're talking about solving absolute value equations. We're talking about literally solving an absolute value equation. So really basic, right off the bat, you might have something like the absolute value of x minus 7 is equal to 2. Well, some of you can see that if I put a 9 in here, if this is a 9, 9 minus 7 is 2. And that's true. But it's only half of your answer, because what would happen, so we have to look at what happens, take kind of this over here, 2 different times. What if we get x minus 7 in here equals 2? Well, what if that's a positive 2? The absolute value of 2 is 2, right? Well, what if the absolute value is negative 2? Well, the absolute value of negative 2 is also 2. So we need to know what happens to this on the left-hand side if the stuff inside is both positive and negative. So while 9 minus 7 is 2, 5 minus 7 is also, like, if this was in absolute value bars, I can't seem to make them. If this was an absolute value bar, oh my gosh. If this was an absolute value bars, there we go. 5 minus 7 is the absolute value of negative 2, which is 2. So this is true. All right, so just in case I've completely and utterly lost you, I'm going to give you some rules to see what happens. But here's kind of a big thing. So the stuff inside, I'm being very mathematically technical here. The stuff inside the absolute value bars can be a positive or negative value. Right? And so we need to account for both of those when we solve a problem. So because of that, we will solve for both cases when you see absolute value bars in a problem. Okay, so I am going to give you a couple of rules for these. I'm going to give myself another screen. So remember down here, you're labeling. This is 1.4. All right, so here's an example of an absolute value problem that we're going to see. And it looks something like 2 plus the absolute value of 4x plus 1 is equal to 6. All right, well, there's two things that you need to check before you solve. And here's what they are. The first one is number 1. You need the problem to be set up as. So does the problem look like absolute value bars equal some number? Some, and we'll be more specific. That some number has to be 0 or positive. Okay, and here's what I mean. In this equation, here's your absolute value bars equal some number. But this thing is still here, that 2 plus the absolute value bars. That can't happen before we go any further with this problem. So if you have anything either added or subtracted to, or even multiplied by, and that could look a little bit different, you need to make sure you undo add or subtract, or even, well, yeah, or multiply or divide before you move forward. Okay, so if the answer to part 1 is no, you need to make sure that this happens first. So what I mean by that, this little guy has to go away. So it's 2 plus the absolute value, so I'm going to subtract off 2 and subtract off 2. That's going to now leave me the absolute value of 4x plus 1 is equal to 4. And now I have absolute value right here equals some number, and that number is 0 or positive. So now our problem meets criteria number 1. That's the first thing you have to do. I can't say that enough times. You guys, I've been doing this a long time. This is year 19 teaching. That is one of the biggest mistakes kids make, is they don't move anything away from the absolute value in this section, and it creates havoc. So now what we need to do is check what happens when we do find both of our answers. So does the problem look like that? That's question 1. And then 2, oh, I'm going to make this a different color. 2, is the answer 0 or positive? And by that, I mean that is the answer 0 or positive. If yes, continue. If no, then you cannot have absolute value equals some negative, so you would have no solution. We'll do, oh geez, that's not going to fit. We'll do one like that in a little while, but I'm going to keep asking you to do these. Check for steps 1 and 2. So these two things need to happen before you continue. So we took care of 1. The answer to question 2 is yes. So now what you're going to do And I want you to set your paper up exactly the way I'm going to set mine up. Now you're going to do case 1 and case 2. And case 1, oh, that was supposed to be an arrow. Did you like that? Hold on one second. So let's lay this out a little bit more clearly. So case 1 is where you're going to drop your absolute value bars and keep the answer positive. Okay, so before we even focus on case 2, here's what case 1 is going to look like. You're going to drop your absolute value bars from up here, so just 4x plus 1, and you're going to keep your answer positive. Okay, we can go ahead and solve that. So we're going to take off a 1, 4x equals 3, divide by our coefficient, and x would equal 3/4. Okay, so that's case 1. Case 2, you are going to drop the absolute value bars. Ugh. I'm sorry. My brain is going faster than my hand can actually write. So we're going to drop absolute value bars and make, not keep, make the answer negative. Okay, so the reason we're doing this, here's case 2. Drop the absolute value bars, but make your answer negative. The reason we're doing that is because, remember, the stuff in here can either be 4 to equal 4, or it could be -4, right? Because the absolute value of -4 is 4. So case 2 is what happens when the stuff inside is actually negative, and that's why we're solving that. So we're going to take off a 1. 4x equals -5. Divide by 4. And x equals -5/4. And so you're going to see in varsity, you would see the problem up here, and then you're going to see x equals a box, comma, a box most of the time. And it doesn't matter which one you put where. You could put this one there and that one there. It doesn't matter as long as both answers are in there. Okay? So that's how we're going to do all these. Absolute value has to be equal to a number. Absolute value equals a number. Then you're going to do case 1 where the answer is positive, case 2 where the answer is negative. You're always going to have, most of the time, you're going to have 2 answers. All right, let's go from there and do the next one. So here's another example. Let me flip my page. This could be a little loud. All right, let's take a look at this one. Is really daunting looking, but it's actually a little simpler. Absolute value of 4 times 2x plus 5, close paren, minus 5, close the absolute value bars, equals 3. Okay, so that's our problem. And remember, question 1, do you have absolute value equals some number? Yes, we do have that here. Because, I mean, yes, there's a lot inside of the absolute value bars, but there's nothing on the either side, left or right. So some highlighter. There's nothing out here in front, and there's nothing behind the absolute value between that and the equal sign. So that's where extra stuff would have to be, right? Going back to that other problem, let's just point this out. I'm going to zip back to here in your notes. In this problem, in the original, you had that 2 out in front, right? So that's why that had to be moved. You could also look between the absolute value and the equal sign, and there's nothing there. So this would be the only thing the 2 would have to be dealt with. Now in this one, that doesn't happen. So we actually, yes, we do have absolute value equals something. Then question 2 is the something positive or 0? And that means this value. And so, yes, again. So now we can do case 1 and case 2. Okay, and I want you write these out. Write the words case 1, underneath of it, write the problem. Equals the positive answer. Then over here, case 2, write the problem. Equals whatever this is has to become negative. Okay, and now we're going to solve both parts. And you can kind of solve them simultaneously if you want. I mean, this left side's identical. So this is going to give me 8x plus 20 minus 5, 8x plus 15. Well, I'm going to have exactly the same thing over here, right? 8x plus 20 minus 5, 8x plus 15. And here's where it gets a little bit different. Now when I subtract off the 15, here I'm still going to subtract off of 15, but I'm getting a very different piece of information. So 8x is equal to negative 12. And over here, 8x is equal to negative 18. Divide both sides by 8. And remember, you're going to reduce these answers. So here, x is going to equal, I can divide these both by 4. So that's going to be a negative 3 over 2. And this guy, those are going to cancel. I can only divide these by 2. I can't divide them by 4. So this is going to be negative 9 over 4. Okay, and those would be the two answers. Now, again, if you wanted to, you could check these, put all that information back in, and go from there. Okay. Again, this is 1.4 in your notes. I'm done with a page. I'm going to go and just point out a couple things in a couple different problems. So here's another problem. For the absolute value of 4x minus 6 equals 0. Well, question 1. Do you have absolute value equals some number? And the answer is yes. So you can continue. Number 2, is the number either 0 or positive? And the answer to that is yes. And so we can continue. Now, if your answer is 0 over here, since 0 is what's called a neutral number, meaning it has no sign, it's not positive or negative, you will only have one case. Which also means you will only have one answer. Therefore, only one answer. So when you solve this one, you'll go directly to 4x minus 6 equals 0. Move the 6. Divide by 4. Reduce. And that's the only answer you're going to have. So if you have a value, a positive number here, you're going to get 2 answers. But if you have 0 over there, you're only going to get 1 answer. Okay, another thing I want to point out. If you have a problem that looks like this, you have to be really careful. Absolute value of 6x plus 3 plus 7 equals 5. All right, so the first question, as always, is do you have absolute value equals some number? Well, the answer is no here. And the reason it's no is because in front you're okay. There's nothing there in front of the absolute value bar. But behind the absolute value bar, we have this plus 7 hanging out. So we need to deal with that before we can move on. And in order to deal with that, we are going to subtract off 7. Well, when we do that, we get absolute value of 6x plus 3 equals -2. Well, your question number 2 is the number, this number right here, 0 or positive? And if the answer is no, then you have no solution. Which in varsity, if you get one of these, you would put DNE for does not exist, unless it's a multiple choice question and they have a no solution as an answer. Okay. But what's happening here is, can you ever have anything in the absolute value bars in here equal something negative? No, it can't ever happen, ever. So you have no solution. Those are trick questions. I like to throw them out in your direction. All right. I think that covers it. So again, this was notes for 1.4. You're going to take pictures and submit to Google Classroom. I think I forgot to put that in your last set of notes, but I feel like the learning curve has already happened. So, all right. Also, we are getting close to a test, a chapter test. And I just want to remind you that you can use these notes on tests and quizzes in my room, right? So you should have your spiral notebook. So your option was for your notes, spiral notebook with only notes in it. Or 2, if you're typing out your notes, you make sure you have a printed copy and they're put in a 3-ring binder. Okay, those are your only 2 options you are allowed to have on your desk aside from a calculator when we do this. So if you have done your notes electronically in Google or something, and we get to the test and you say, oh, I didn't print them out, too bad. You don't get to use any notes on your test. You may not access them electronically. Okay, I stated that in the video at the very beginning of the year. I'm not going to budge on that. So if you don't have notes, if you leave your spiral notebook of notes in your locker when you come to class and you don't have notes for your test, too bad. Come to class prepared. You guys are young adults, almost graduating high school. You need to come prepared. So make sure that happens. We have one more section before a test, and then we'll see where things are. Toodaloo.